The invention of the transistor revolutionized the field of electronics. And paved the way for the development of modern electronic devices such as computers, smartphones, and televisions. A transistor is a semiconductor device that is made by doping a semiconductor material. Such as silicon or germanium. Doping. The semiconductor wafer is doped with impurities to create p-type and n-type regions. P-type regions have an excess of positively charged holes, while n-type regions have an excess of negatively charged electrons. Valence electrons are the outermost electrons in an atom that are participated in chemical reactions. This is a silicon lattice. With 4 valence electrons. Phosphorus or arsenic are intentionally introduced into the semiconductor crystal lattice. The extra electron is not bound to any atom, creating a free electron. The resulting material is called n-type semiconductor. During p-type doping, atoms of impurities such as boron or aluminum are intentionally introduced into the semiconductor crystal lattice. Creating a hole or electron deficiency in the lattice where the covalent bond is missing. The resulting material is called p-type semiconductor. When an n-type and p-type are brought together to form a p-n junction, it results in the creation of depletion region, which is the region in semiconductor where the concentration of free carriers, such as electrons and holes, is reduced. This happens due to the diffusion of minority carriers across the junction. The p-n junction has many applications in electronics, including such as diodes and transistor. The transistor is represented as a sandwich of 2 layers of n-type material, the emitter and collector, and 1 layer of p-type material, the base. When a voltage is applied across the collector and emitter, electrons flow from the emitter to the collector through the p-type base. However, in its natural state, the base is not conducting current because it has no free electrons or holes to carry the charge. Let's see in the circuits. With no current or voltage is applied at the base, the LED is off. Now, when a small current, or voltage, is applied to the base by pressing the switch. It causes the base emitter junction to become forward biased, allowing a flow of electrons from the emitter to the base. These electrons cross the base and are then attracted by the positively charged collector, causing a large current to flow from the collector to the emitter. Emitter. The emitter is the pin through which the majority charge carriers, electrons or holes, flow out of the transistor. In an NPN transistor, the emitter is doped with impurities that provide a surplus of electrons. Base. The base is the pin that controls the flow of charge carriers between the emitter and the collector. By applying a voltage or current to the base, the flow of charge carriers can be amplified or controlled. Collector. The collector is the pin through which the majority charge carriers flow into the transistor. In an NPN transistor, the collector is doped with impurities that provide a deficit of electrons. The arrangement of these pins can vary depending on the type of transistor and the specific circuit application.